the Leeds and Liverpool Canal. Links two counties that have never quite seen eye to eye across the spine of England, the Pennines. And it made them, Yorkshire and Lancashire, very rich indeed. Thank you very much. But how?
The story begins here, in the Pennines.
Meh, meh.
The land in Yorkshire and Lancashire is notoriously poor. That's why there are so many of these lads about. Grass is the easiest thing to grow. But in the 18th century, farmers realised that adding lime to their soil would increase their yield. The first section of the Leeds-Liverpool Canal was built in Yorkshire in 1770 to transport limestone from the local quarries at Craven. But this lime had a knock-on effect.
Using lime for fertiliser meant that fewer people could grow more food and release workers for other jobs. And these workers were moving to the new industrial centres, and Britain was going through a building boom.
Luckily, lime also makes great mortar, and so as the building increased, so did the demand for lime carried on the canal.
But it also became an important trade route for another cargo, woolen goods.
After all those sheep had to be good for something. This is woolen thread. And this is a frame loom. It's very basic. This is the warp running up and down, and the weft crosses it. So, to weave, you pass the weft up and over each of the warps. It does the job, but it is, as you can see, a very time-consuming and very laborious. And if you're a big strapping Yorkshireman trying to keep your family, it's no good.
So, when this came along, weavers could actually make a living out of their craft. This is the hand loom and represents a significant improvement. Same principle. Here's the warp and the weft goes through. But this loom got a piece of kit invented in 1733 by one John Kay that doubled the output of these looms, and it was this. The flying shuttle. Only not very flying. So, instead of throwing the shuttle through the warp, you can now just whack it across. And the weavers would keep it in the family. The children carding, the women winding bobbins and spinning, and the men up here weaving. You can see how big the windows were. They'd want as much natural light as possible for these fine yarns. Another thing they used to do to gain as much possible light is to give their walls a lime wash. Lucky there was plenty of it about.
The flying shuttle was a major breakthrough. Weavers could now earn a living selling their cloth, transported to market on the canal. But as work on the canal progressed, there were arguments about the route west.
The Yorkshire entrepreneurs also saw it as a trade route to America, so once over the Pennines, they wanted to head direct for Liverpool. But the Lancastrians wanted a winding canal, connecting the coalfields of Wigan with their rapidly industrialising towns. And the canny Lancastrians got it right. There was 10 times more coal carried on this canal than was ever expected, and 10 times less limestone.
It was coal that fed the newly industrialised northern towns, carried on a boat unique to the Leeds-Liverpool Canal.
The dimensions of the Yorkshire and Lancashire coastal boats, the flats and so on, were about 18 metres by 4 metres. And the canal canal's engineer, John Longbottom, decided that those would be the dimensions of his canal. It's a big northern canal, not a soft southern one like the one that Brindley was digging.
And it was built for speed, with a series of features designed to get the boats moving quickly. Rollers on tight bends to stop the tow rope fraying. These turnover bridges, which means that when the towpath swaps sides, the horse can cross over and under the bridge without having to be untied. Rungs on lock gates, so the boatman can climb out of the lock as the boat enters.
And this is one of the masterpieces of canal engineering. This is John Longbottom's Bingley 5 rise. There are 5 locks here, but there's no pans in between. Each lock leads into the next one. So in 18 metres of height, we only move 100 metres. It's a masterpiece of compression. OK, 1, 2, 3, 4, 5. The basic principle is that only one chamber is empty at any one time. So you arrive from the bottom level into an empty chamber and you have to have the other 4 full, because the second one goes into the first one. So then the third one has to go into the second one, 5th into the 4th, 4th into the 3rd, etc, etc. So the water carries you up until you get to the 5th level. But in actuality, people can tie themselves in knots. If you look down, there's a lot of paddles there and a lot of confusion.
And without the help of Barry, the lockkeeper, it's easy to be left high and dry.
This is a ground paddle, and Barry's just drawing it bit by bit. It leads to a culvert which goes around to the next chamber, here, where the boat is. There's the boat, down there.
And you can see where water comes in from the ground paddle.
The paddle that Barry's standing at now is the gate paddle. And that paddle is at the moment about 9 feet above the boat. So you don't want to open that one just yet. It's almost a machine. It's sort of conceived and built in one piece. It's almost as if it's been chiselled out of this piece of hillside. Just sits here. It's fascinating, and it's also a bit more than that. It's a sort of monument. It's a monument to ingenuity and persistence. And I think that if you want to call yourself a venture capitalist or an entrepreneur, you should come and have a look at this, which was built in the late 18th century, and see if you can do any better.
The canal took 40 years to be completed. Work stopped for 7 years when the canal company ran out of money.
Finally, it was finished in 1816, all 141 miles of it.
With the canal came a massive increase in trade and industry to Yorkshire and Lancashire. The cottage industries of the region, wool and cotton manufacture, were becoming mechanised, but weaving lacked a usable power source. Spinning mills sprang up around fast-flowing rivers, utilising running water to power the new-fangled spinning machines, cotton in Lancashire, wool in Yorkshire. But weaving couldn't utilise water in the same way. It's difficult to get a constant speed from a water wheel, and if you haven't got a constant speed, the weave isn't uniform enough.
So, they came up with this. Whereas on the hand loom, the pedal rotates the lifting of the sheds, on this one, the pedals do everything. Lifting the sheds, throwing the shuttle, the lot. So, if you could pedal, you could weave.
Each shuttle throw is called a pick, and this loom works at 120 picks per minute.
Of course, you wouldn't necessarily just do nothing all day. You can improve yourself spiritually. Perhaps you could sing some hymns. Dear Lord and Father of mankind, forgive our foolish ways.
We clothe us in our rightful mind, in pure. The lives thy service find, in deeper reverence praise, in deeper reverence praise.
But it was still one person, one loom, and until that changed, weaving wouldn't really be revolutionised. What you needed is something that could power a whole stack of looms at once. The Leeds Liverpool Canal was built with the intention of carrying limestone, but ended up carrying much more coal than was ever expected. So, all these salt boats carrying all this coal, where are they going? Here, to fire the boilers of textile mills. The textile industry had found a way to allow the new steam engines to power their machines. With the canal able to provide coal and raw materials, massive weaving mills sprang up. This one is at a museum, the Queen Street Mill. There's only one boiler working now, and that gets through 10 tonnes of this a month. But when both boilers were going at full steam, the boilerman down here got through 6 tonnes of coal a day, 6 days a week. Steam power had finally arrived in the textile industry. And this is what the boilers are generating steam for. It's a tandem because there are 2 cylinders, one in front of the other, like a bike. Compound because the steam is used more than once. Condensing because downstairs is James Watt's separate condenser, creating a partial vacuum in this, the big cylinder. Steam engine. All right, Owen? It develops 500 horsepower and it drives this 4-metre diameter flywheel. And I can feel the air off that. This engine, powered by coal, transported on the canal, was built by Roberts of Nelson in 1894 and drives the looms of this Lancashire cotton mill. Mesmerising, isn't it? That's the crosshead. Connecting rod to the crank there, which is turning the wheel. All that power. Then you look down here, and these are going the wrong way. What's that all about? Well, what's happening with it going against the piston movement is that he's controlling the inlet valves and the exhaust valves. So it's got to work against the piston because you've got to put the steam in behind it. Hang on a minute. Right. OK. So that's coming backwards and lifting. Every time it lifts, that's an injection of steam behind the piston one way and the other side the other. OK, so what's happening down there? Well, you've got to get rid of the steam as well, so these are the exhaust valves. Ah, but they look like they're both going the same way, and you think, oh, that's not right. But they're set at 180 degrees. So when one's open, the other one's closed, so the rod can just work together. Good, isn't it? And this is my favourite bit. Dancing metal. It's like little punches, isn't it? She's even got a name, and I think it's a measure of the respect that the Victorians had for these masterpieces of engineering. She was originally called Prudence, after the wife of the engineer, but was renamed after the 1918 armistice. Of course, the other side of the wheel wasn't quite so measured and tranquil. Because this is what it's driving. 300 power looms. You can get an idea of how loud it is, but you can't feel the concrete floor vibrating. These are much more advanced than the pedal looms, weaving at 180 picks per minute, as opposed to 120 for the pedal loom. Now, everything is powered by steam. All the weaver has to do is change the weft in the shuttle and maintain the loom. So one weaver can look after 8 looms.
The power loom was invented in 1786 by a rector, Dr. Edmund Cartwright. It wasn't just a case of connecting a steam engine to a pedal loom. Weaving 50% faster required a loom with greater tolerance. Mill owners loved it, especially the cotton barons of Lancashire.
But they took a while to catch on in Yorkshire. Wool was more delicate than cotton and harder to weave. By the 1830s, the first power looms appeared in Yorkshire, but they still needed some fine-tuning. By the 1850s, there were about 4,000 of them. But by 1874, there were 30,000 of them running.
Steam-powered woolen mills sprang up around Yorkshire, nowhere more so than in Bradford, already a trade centre for wool. But it had no canal link. After all, the Yorkshiremen had built the canal for limestone, so they built a branch to it.
And it made Bradford very, very rich. This unassuming little necropolis is where the great and the good of Bradford were buried. Not particularly modest about their wealth, even in death. But this wealth came at a price. Bradford was a cesspit. It was said that the canal would turn a silver watch black. A German poet, Gregor Werth, said of the town, "I would not have felt any different if I had gone straight to hell. Every other factory town in England is a paradise compared with this hole. If any man wants to know how a poor, tormented sinner feels in purgatory, let him travel to Bradford." All this filth meant that the life expectancy in Bradford in the 1840s was 20 years and 3 months. Whoopee. For a rich industrialist, this was a pain. Having your workers dropping dead on you was inefficient. And so was having 5 mills dotted around Bradford, as mill owner Titus Salt did. So he started looking around for new premises. Salt needed water to wash his fibres, in very short supply in Bradford, more space and transport. So he moved out of town, 5 miles into the countryside, where he had plenty of land, the River Aire, and the Leeds-Liverpool Canal ran right past his back door.
Now steam was driving textile production, you could build your mill almost anywhere along the canal. And the Leeds-Liverpool Canal connected Salt's mill to the world.
Salt worked alpaca, and this mill could take alpaca from the canal, imported to Liverpool from South America, and turn it into a finished product. Alpaca is a quality weave, and it made Salt a rich man. So when he built this mill, he really went for it. Impressive, isn't it? But this is only the back entrance. You should see the front. Now that's a mill. 5 stories high, 40 bays long, 10,000 square metres of working space. Fireproof with stone flagged floors and Corinthian cast iron columns. It has voussoired arches, rusticated pilasters, and it got its power from 10 boilers powering 2 double beam engines producing 1,250 horsepower each, and it produced 18 miles of alpaca cloth a day.
The cottage weavers couldn't have imagined that kind of production. The canal had revolutionised the textile industry, but some things had remained the same.
Old habits in weaving seemed to die hard. Titus Salt grouped every single process, from raw material to finished product, under one roof, exactly the same as the old family weavers. And like them, he needed as much natural light as possible. So this whole building has these huge windows. And it's now a gallery. It holds the works of another famous son of Bradford, David Hockney. And it's a very nice gallery. There's something about the materials, the stone-flagged floors, these cast iron hoppers that held the weavers' tools, these great massive stone lintels that still bear the marks of their sharpening. It's nice. Like his alpaca wool products. Good quality stuff. He was so loaded, economic conditions working so well for him, along with his technological improvements, that he could afford to indulge his tastes.
He had just come back from holiday in Italy, and so designed his work as a village in an Italianate style, giving the streets good Italian names. The cottages had a room with a view of the mill. With his employees in company houses, Salt had his workforce just where he wanted them, under his thumb.
Modestly, he called this model village Saltaire. So, the Leeds Liverpool Canal turned the textile business from something done in family homes into a major industry, and along the way created millionaires and tycoons. Not bad for a big ditch. Hey. Next time, I'll be looking at developments in the iron industry, which led to extraordinary feats of engineering. Treasure. See? Flotsam and jetsam. Boatman's rights.